Hello guys, welcome back. This is your online tutor, Professor Mandona John, and we're going to continue from where we ended in our last lecture tutorial. So we're going to continue in chemistry, and under chemistry we were actually dealing with what we call the Bohr's model. So under the Bohr's model, we actually discussed to say if we have an atom, so that is an atom. So if we actually have an atom there, and this atom, let it be an atom of hydrogen. And we already know that this atom of hydrogen actually only has one electron. So this one electron, I'm going to place it on the first energy level. And we know that this first energy level is denoted with N. Sorry about that. N is equal to 1 as our quantum number for that energy level. So if this energy, this electron is moving from the first energy level going to any other energy level, let this move to the third energy level. It means that this electron is actually going to gain energy. So energy will be gained in that direction. So this energy which is gained is going to be a negative. Oh, sorry, it's going to be a positive. So the energy gained by this electron will be positive, which is going to cause this electron to transition from the lower energy level. In this case, it is placed on quantum number 1, and it is going to go to the third energy level, and this energy level is symbolized to be quantum number 3. So there is what we call the gain of energy by this electron for it to transition from the lowest shell to the third shell. And one thing that you're supposed to know is that as an electron is transitioning from any energy level to the other, it absorbs energy in form of what we call photons. So a photon is just a quantum of light. So this quantum of light is actually emitted or gained by this electron for it to transition from one shell to another. So the opposite of this statement is also true, whereby if we have an electron, let it be on this energy level quantum number 3, this electron can actually also transition going downwards to the first energy level, and as it goes downward, energy is actually emitted. As energy is emitted, it will have a negative. So this negative is only showing to say that energy is being lost by this electron there, which is from the highest energy level containing the highest amount of energy, going to the lowest amount of going to the low energy level, and as it emits energy in form of photon, it will possess a negative charge. So this is actually what happens when we explain the transitioning of electrons from one energy level to another. Saying if an electron is transitioning from the lowest energy level to the highest energy level, it is going to absorb energy so that it can fit that energy level in form of photons, which will actually carry a positive sign. And if an electron is transitioning from the highest energy level going to the lowest energy level or any energy level below it, it will actually carry a negative sign. And this negative is actually trying to say that it is emitting electrons. So that is how it is. So now, to continue, we are actually going to try to explain how we can calculate the energy or the energy released or the energy gained by this energy by this electron. So when an electron is moving from one energy level to the other, as I earlier said, to say that it gains and emits energy. And we actually need to calculate the change in energy between the two energy levels. So let us try to dive in to explain that. So according to Bohr's model, energy can actually be calculated using the formula to say energy is equal to the Planck's constant, which is actually multiplied by the frequency. Energy can be calculated if we multiply the Planck's constant with the frequency. And where the Planck's constant, this is actually called the Planck's constant. The value for the Planck's constant is 6.626 multiplied by 10 to the power negative 34. It is a constant number. So this is what we're calling the Planck's constant. So h is the Planck's constant having that value multiplied by the frequency. We can use this formula in order for us to find the energy of an electron in that position, which means in that energy level. But the same is also true to say we can have the speed of light, since energy is emitted as photons, which is a quantum of light. So the speed of that light which is emitted by the electron is actually equal to the speed of that electron is actually equal to the frequency times the wavelength. So in order for us to find or to calculate so to rewrite that one, sorry for that, the formula for the speed of the same light is equal to the frequency multiplied by the wavelength. This is actually the wavelength, and C in this case will be symbolizing the speed. C will be symbolizing the speed, and the speed of light is actually given as 3 times 10 to the power 8. That is the speed of light. So to conclude with this formula, we can say that energy is equal to the Planck's constant, and where there is the frequency, where there is a frequency, I'm going to multiply the frequency with the speed over the wavelength. If at all I try to make the frequency the subject of the formula, and I'm going to substitute it there. So this will be my formula for the energy. So now, how do we actually calculate the change in energy? Because we are actually moving from one energy level to the other. So how can we actually calculate the change in energy? So in order for us to calculate the change in energy, allow me to erase this part. In order for us to actually calculate the change in energy, if this electron is moving, in this case it will be moving from the first energy level and it will transition to the third energy level. So as this electron transitions from one energy level to the other energy level, it is actually changing in the values of energy. Why? Because this energy level has the lowest amount of energy and the other energy level has the highest amount of energy. So which means that there is change in energy there. So the change in energy is denoted with a simple triangle there. The change in energy is denoted as that. And we can say, we can actually calculate the change in energy if we use this formula to say the negative of the Rayleigh constant. And we are going to multiply 1 over n squared f minus 1 over n squared I. So that is the formula that we are going to use in order for us to calculate the change in energy. So now, what does it actually mean? The n squared is actually symbolizing the energy level. Now, this F and that I is actually symbolizing the final and the initial. So, how do we actually find out the final? And how do we actually find out the initial? The initial energy level, which is N, is the energy level the electron is coming from. So in this case, the energy level is coming from, and the electron is actually coming from the energy level 1, which is our initial, and it is going to energy level 3, which will be our final. So in this case, the initial energy level is 1, and the final energy level is 3. So if we are using this formula to calculate the energy, the formula for the Rayleigh constant there is going to be, the Rayleigh constant is going to be 2.18 times 10 to the power negative 18. This will be in joules. So this will be our constant that we're supposed to know. We're supposed to know that constant. So now, after knowing to say that we're supposed to use that to calculate the energy, we can also calculate the wavelength because it is light which is being emitted. So since it is light being emitted, we can actually calculate the wavelength. I am just introducing this concept. So in our next video, we are actually going to learn how to calculate the energy. So in order for us to calculate the wavelength, we can use this formula to say the wavelength is equal to the Rayleigh constant multiplied by 1 squared f minus 1 n squared initial. The concept about the initial here is still the same. The initial energy level, the quantum number, is where the electron is starting from. In this case, the initial is equal to 1 and the final is equal to 3. But here I'm going to explain the Rayleigh constant in this case. So the Rayleigh constant, if we are calculating the wavelength, is 1.09 times 10, 1.09 times 10 to the power 7 per meter. So this is our Rayleigh constant if we actually need to calculate the wavelength of the photon that is being emitted between two energy levels as it transitions. So we are going to continue in our next lecture from here so that we can know how to answer using these formulas that I've given. Thank you very much.